Hi everyone and welcome to this video. So today we are going to do the interim analysis of the data that we have gathered in the IMS score calculator and percentile predictor. I'll be talking about the slot wise and the section wise data. We'll be talking about the analysis and I'll give a comment on the scaling that is expected for each of the slots and the sections. And we'll also talk about the overall score versus percentile that you can expect. Now, before that, one thing, all of this is coming from the analysis that we have done on the data that we gathered using the IMS score calculator and percentile predictor. So make sure that in case you haven't done it already, you submit your data here so that you'll be able to see your predicted percentile and the scaled scores as well. Now, yesterday, of course, a lot of drama happened. I'm sure everybody is aware of it. Firstly, IMK released the response sheet. The response sheet had issues when it comes to the theta questions in the quant section for everybody. So whoever checked their scores yesterday or the response sheet yesterday, they basically were not able to see any right answer for the theta questions in QA. So today morning, IMK realized that and they fixed it, but that URL is different from the URL which was there yesterday. So the only way to fix that, the way we fixed it, is basically we have mapped the right answer key at the backend. There is one more important thing that you need to note here, and especially this is for slot 1 students, that in slot 1 there is a quant question for which the answer key that is given is incorrect. We have checked it across various, we asked all the mentors and the students as well. Whoever solved it, basically we have finalized that, okay, that's not the right answer. So there is a right answer according to us. I think the right answer is 0 for that particular question. So we have rectified that in this particular score calculator. So those of you who have already used it, your scores have been updated. And in case somebody uploads it fresh, you will still be able to see the right score. So whatever you see here, the scores are getting calculated in the right manner. So that is a note for slot 1 students. For slot 2 and slot 3, at this point of time, there are no questions that need to be challenged as such. Maybe VRC, we might have something at a later point of time. But right now, at least there's no issue with the answer key. So make sure that you use this. The prediction right now, we at the time of recording this video, we have close to 30,400 submissions in this. As we progress, of course, tomorrow and day after tomorrow, we'll have more submissions. So this is happening in under less than 24 hours at this point of time. Okay. The analysis that we have done was done on a data which is about 26,000 plus data points. Since then, the count has gone up. Okay. So let's get into the analysis. And what I'm going to do is, firstly, I'm going to talk about the individual sections. And I'll talk a little bit about how the scaling can happen this year. Okay, so what you see is firstly this graph. The graph is not super important because there isn't a lot of data that you can immediately gather from this, but this is just for you to understand how the scaling, how the distribution was. Okay, so if you see that, firstly, the CAT distribution is never like a normal distribution, right? You're going to have the area under the curve differs a lot. So if you look at, let's say, from a particular range, the area under the curve will be very small. Then in some ranges, it will be huge, right? So the scores tend to get concentrated in certain ranges. Okay, and as you will see, a lot of people get into negative score as well. So for each of the sections, you will see a graph like this, but that's not going to help much from getting data immediately. It's just for a visual representation of how the distribution is looking at this point of time. Now, what happens also because of this is that, and when you look at the overall scaling as well, it's not that everybody's score will get scaled up or scaled down by the same amount, right? Because it depends on the way students have performed in that particular slot. And when you look at all the slots together also, what the performance has been, right? So that is why scaling is a complicated mechanism. It's not something that you will be able to see just by looking at a graph that what is going to get scaled up or down, because there are crossovers that happen, right? So you will see that for a particular slot, you will see concentration happening and there will be say a peak, right? Because the density is higher, okay? But whereas in some cases, it will be slightly flattish. So this not that important, but what I want you to focus on is this, right? So basis the data that we got and we perform the same calculations that IMs do when it comes to scaling, what you see is mostly for slot 1 and slot 2, right? When you look at the VRC scores, and you can, the first column, the VRC column that you see there, these are basically raw score. So a raw score of, just to give one example so that everybody understands what I'm talking about, a score of 50 in VRC, in slot 1 that is, will get scaled up to 52.42. In slot 2, it will get scaled up to 53.15. In slot 3, it will get scaled down to 47.28. Okay, so that is based on the interim calculations that we have done, right? See, tomorrow we'll get, let's say, another 10,000 data points. The scaling will change because of that. The scaled scores is percentile tables, and everything that you see in this video, the data points will differ. But at this point of time, the way things stand, when it comes to slot 1 and slot 2 for the VRC section, the scores will get scaled up. Okay, you will see slight aberration happening in the lower ranges, and again that can happen because of the way the distribution is. Okay, but or it is mostly because of the data points that we have. See, right now we have a very limited set of data points, right? If you look at the total audience, which is 2.58 lakh takers, out of that, when we are doing analysis on 26,000 students, though again we'll have a lot of students across the range, and as you can see here, there are a lot of people in the negative zones also, going as close to say even minus 15, minus 16, and so on. There will be a lot of students who are performed on the lower end of the spectrum and have not been captured at this point of time. Okay, so that is why there will be a little bit of aberration here and there, but more or less slot 1 and slot 2 for the VRC section will get scaled up, whereas slot 3 will get scaled down. So the other way to interpret this is to say that slot 3 had possibly the easiest VRC section, because of which people have scored on the higher side, and you will see that happening here, right? So if you can just focus on this end of this tail, you will see slot 3 is on the higher side compared to slot 1 and 2, right? And this is particularly at a score of beyond 40 or even beyond 30, you can see that same thing happening. So that is why slot 3 will get scaled down when it comes to the VRC section. Let's move on to the next section, which is DILR. Now again, for DILR, if you see, the peak is happening somewhere in this range, so you'll see a lot of concentration between a score of 0 to 20 across the 3 slots that are there, right? But again, if you look at this, you will see this is slot 2, which is the blue in color. That is where people have performed on the higher side, especially if you look at the 30 plus range. So the interpretation of this, right, is when it comes to DILR section, again, let's take a particular data point. 40 raw score will become 46.07 in slot 1 roughly. Again, don't take after the decimal point, things can differ, but somewhere around 46, somewhere in the ballpark of 36, and somewhere around 49 when it comes to slot 3. So slot 3 will get scaled up significantly when it comes to DILR section. So if I have to say slot 1 will get scaled up, slot 3 will get scaled up, right? Whereas slot 2 will get scaled down. Okay, so slot 2 appears to have sort of the slightly easier DILR section compared to the other 2 sections. At least that is how students performed on those sections. So that is how it will be. So slot 1 and slot 3 will get scaled up, whereas slot 2 will get scaled down. Okay, let's move on to the third, which is the QA section. So in QA section, again, if you look at it, when you look at the blue one, which is slot 2, again you will see comparatively it is on this side, right? So people have slightly performed better in this particular slot. So when you look at the 3 slots, again comparison, let's say for example a score of 30 in QA in slot 1 would get scaled up marginally. So this is a marginal scale up. Overall scaling is still going to be down. So that's why I said that sometimes the scaling will get impacted because of of course the nature of data points, what sort of students have submitted, and the other thing is, of course, when you look at it from a larger standpoint, you don't have all the data points, right? You're working with limited data set, and that is why there is going to be some impact. So for example, the standard deviation will get impacted, the distribution will get impacted. So overall impact on slot 1 is going to be scaled down. As you can see at the top, for example, a score of 45 will become 44. Marginal scaling is what it is, right? So marginally scaled down, that is what is going to happen. Whereas for slot 2, again, it is going to get scaled down. So say a score of 50 will become 49.87, a 30 will become 28.42, and you see everything is getting scaled down. So say a score of 15 will become roughly 12 point something. Now, when you focus on slot 3 instead, that is where the slot 3, if you look at it, difficult section when it comes to QA, scores will get scaled up. So say for example, a 35 will get scaled up to 37.25, and this is where you see universally things are getting scaled up. So everybody in slot 3, when it comes to quant section, will have an upward movement when it comes to their scaled score. So say a score of 50 might become something like a 52.67. So the point of all of this discussion, right, is for you to get a sense of what scaling can be, After the decimal point, as I said, there are going to be changes because of course nobody is operating with perfect data. So this is based on that interim analysis, and let's assume that the sample that we have is representative of the population that exists. Now let's talk about raw score versus percentile estimate. So when you look at the raw score versus percentiles, so what I've done is on the leftmost column you have the percentile mentioned, and what raw score in particular slot would give you that particular the percentile. So when you say, for example, 98 percentile, a raw score of 38 in slot 1, a raw score of 36 in slot 2, and a raw score of 40 in slot 3, right? So that would typically take you to 98 percentile. And similarly, we have given the scores for the other percentile. So let's say, for example, you're targeting the sectional percentile, 23, 22, 24, right? And you don't see a lot of change, a lot of difference there. So concentrated in that 22 to 24 range. So if you have scored somewhere in that range, depending on which slot you were in VARC, you can expect to clear the sectional cutoff. Moving on to the next section, which is DILR. So in DILR, say a 99 percentile, right, would be somewhere around 27 when it comes to slot 1. For slot 2, that would be 33. So it roughly means that in slot 2, you can say maybe 2 questions more is what people were able to attempt when it comes to at the higher range, whereas in the lower ranges, that will come down to about 1 extra question. In slot 3, something like a 99 percentile would have been 27. These figures are very close to what slot 1 figures are. So if you look at this, for example, at least till here the figures are very close, but after that the distribution is different, right? So the scores, for example, here a lot of students were able to attempt questions. As you can see, the 75 percentile mark here is 9, whereas here it is 14, right? So the exact distribution will determine what the final scaling and then corresponding percentile will be. Moving on to the QA section. So in QA, you will see 99 percentile in slot 1 and slot 2 around a score of 29. For example, 10 correct questions, 1 wrong question would have taken you there. But for a slot 3, that is 25 questions. So something like slightly more than 8 correct questions, maybe 9 correct questions and then 2 questions wrong would have taken you to a 99 percentile. But as you see here, for the 85 percentile mark, for example, score of 11 only, right? So if you look at the comparison between slot 1 and slot 2, compared to that, it is on the lower side. So even if you're done, let's say 3 correct questions, you would have got maybe 80 percentile. 4 correct questions, 1 wrong question would have taken you to an 85 percentile, which is sectional. So this is where the things stand at this point of time. Of course, as we progress, get more data, the scaled scores will change, and correspondingly our percentile estimates also change. Now what the IMS score calculator and percentile predictor does is that it gets updated at regular intervals. So as more and more students submit, the percentile will keep changing. So the percentile that you see today in your dashboard, if you check it tomorrow, you will see slightly different percentile, and that is because we have gathered more data. So basis that we are calculating the scaled scores, basis that the overall score, and then the percentile that is getting calculated, right? So there's a lot of calculation that is going on in the back end. So as more and more students submit, you will see changes in your percentile. But after a point of time, once it stabilizes more or less, then we will stop updating that algorithm, and then we will use whatever. For example, the moment we reach, say, maybe 50,000 submissions or even 45,000 submissions, we can actually stop that and then have the exact raw score versus scaled score versus percentile estimate. So that brings us to the final thing, which is the overall percentile and overall scaled score. So depending on, again, how things unfold, let's see. But right now at this point of time, at least, this is how it looks. I have taken the 5 percentile difference so that we go till something like 50 percentile. So depending on what your estimated scaled score is, and if you use the IMS score calculator, you will be able to see it. You will see roughly your percentile around that range, right? So for example, a percentile of about 95 would be somewhere around scaled score of 63. 85 percentile would be around 46, a 75 percentile around 36.25, a 99 percentile would be at a scaled score of roughly about 85. Okay, so that these are the current estimates that we have. At the higher range, a 99.9 percentile would be somewhere around 113.xx. 99.5 would be around 94.28. Of course, on the higher side, you will see a lot of people scoring, say, in terms of their raw score, going as high as 130, 140, 150 as well. But that proportion is going to be very, very small, and that is why the 99.9th percentile is somewhere around 113 on the scaled score. So this is where we stand right now, and once we have more data, we'll be coming up with more analysis. Now, what you need to do is firstly check your score. So if you haven't done it already, and even if you have, maybe you tried the score calculator yesterday, so you just got the score but not the percentile. So I'll suggest that all of you log in, and in case you haven't created your account, you create your account, upload your URL. It will show you your raw score, your scaled score, and then your percentile. We have also given few question level stats. For example, for every question, you will be able to see what percentage of the people attempted it and what percentage of the people got it right, right? Just some additional data point if you're doing some analysis. So you check your estimated percentile, and that will help you to make some of your application decisions. But at the same time, understand that whatever predictions we have done, right, is based on a limited data, right? It's a limited sample size. So though we can make broad generalizations, we will not be able to, or nobody for that matter, will be able to give you the exact percentile that you're going to get from the authority. So that is why you use this data point, but work with a plus or minus X percentile range, and then make your B school applications. Okay, so keep that in mind while you look at all of this data. So don't take, or if you take any action or inaction basis this, ideally that is not how it should be. You have to look at it as a standalone point and say, okay, fine, this is my estimated percentile. Let's see what lies in store. But anyway, in roughly about 3 weeks, hopefully the official result should be out soon. Now, if there are any questions where you think that the answer should be challenged, please let us know. And if you have any questions, you can leave a comment and I'll try and get back as soon as possible. Okay. So that's it for this video. Hope it has helped you. Thank you so much for watching, and I wish all of you all the best for the upcoming test that you have, and of course for the CAT result as well. So let's see, if we have a lot of variations, we'll come up with another analysis video, and hopefully that will help some of you. Okay. So bye. Take care. All the best to all of you.